Okay, today's lesson is going to be on velocity. It's not the same as speed. Okay, we've talked about speed already, and we've done some work with calculating some of the problems for speed, but now we're going to talk about what is velocity. Remember that when we talked about speed, we said that speed refers to how fast an object is moving. And we can calculate speed, or we can calculate an average speed, meaning that average speed was total distance divided by total time. We also talked about the fact that instantaneous speed is how fast an object is moving at a given moment in time. Most of the time when you calculate speed of an object, if you're only given one set of time data and one set of distance data, you are calculating instantaneous speed. Velocity describes how fast an object is moving and in which direction it's moving. So for example, if you watch the news at night and you listen to the weatherman, a lot of times he will tell you about the wind and the wind patterns and the speed of the wind and where the wind is blowing to. So for example, he may say that the wind is blowing at 10 kilometers per hour. These are my little clouds showing my wind. And this one, he may also tell you that it's blowing 10 kilometers per hour east. That would be an example of velocity. He's told you what direction the wind is blowing. Here, all he's told you is the speed that the wind is blowing. Okay? Objects that are traveling at the same speed can also have different velocities. Take, for example, my two airplanes. We have this airplane here that's flying at a speed of 300 kilometers per hour, and it's moving in a west position. This plane is moving at 300 kilometers per hour, but it's moving in a northwest position. They're both traveling at the same speed, but they are traveling in different directions. This means that they have different velocities. You can also have vehicles or people or objects that will have what's called a constant velocity. Remember that we talked about constant speed and said that the constant speed is traveling at the same speed over a given amount of time. Constant velocity would be the same thing. They're traveling the same speed, but now you have to add in that they're traveling the same direction. They don't change their direction at all. So they're traveling in a straight line. So this would be an example of being in a car, getting on I-35, and you're going to travel straight on I-35 to Austin. You're not going to turn off left or right. You're going to go straight, and you've put your cruise control on for 70 miles per hour. That would be a constant velocity. But velocity can change. You can put your cruise control on and say that you're going to go 60 miles per hour. But if you're on a curvy road, then your direction is changing. If your direction changes but your speed doesn't, you have still changed your velocity. Same thing here if you were to be driving in a straight line, but you change your speed, slowing down, speeding up, then you have changed your velocity. In order for it to be constant, everything has to stay the same. There are a couple of ways that we will represent velocity when we put it to paper. If we want to show that an object has a velocity, then we can use an arrow that has two tails. And these two tails will show you the magnitude or the strength of the movement of the object. I would say that when we're talking about speed, it's going to tell you how fast. The longer the tails, the faster it's moving. The shorter the tails, the slower it's moving. But velocity will always have two tails. You will also have a point and that point will tell you the direction or show you the direction that the object is moving. If it's moving left, right, up, down, north, east, south, west, whatever. Remember back to when we did displacement. We had the block that was going around, and I had the dotted lines that went through it. And I told you that those dotted lines showed you the path of travel. So when we do some of the representing of our objects on paper, we will use a dotted line to show the pathway that our object is traveling. There's one other way that we can represent velocity on paper. Sometimes it's represented with a positive symbol or a negative symbol. Please know, the symbol only refers to moving in a positive direction or in a negative direction. It has nothing to do with the number itself. Negative doesn't mean slowing down. Positive does not mean speeding up. It simply means the direction that it's traveling. So positive is going to show movement to the right away from start if we're talking about a number line. Negative is going to show the movement to the left or towards the starting point. So for example, when we were talking about speed in class and position and distance, we did some of the number line work in the classroom. Let's look at the number line again. Remember that we said that 0 is going to be our reference point or our starting point. If we move to the right or in a positive number on the number line, we're moving in a positive velocity. We're moving away from start to the right. If we are at the starting point and we go behind or away from the starting point, or we move to the left, then we are moving at a negative velocity. Remember that the negative sign only means that we are moving away from in a negative fashion, not that it affects the number. The same thing would be that if we are here at if we go from 0, our starting point, and we go out to the 2 and we come back, this movement of coming back towards the reference point or towards the starting point is going to mean that we're moving to the left, so it would be a negative. Again, the negative and the positive only shows the direction of movement, has nothing to do with the numbers. Okay, that concludes today's lesson. Thank you.